Take it away, Sean.
Thanks, Craig. Thanks, Walt. So to get things rolling here, why does CASB exist, right? It was a term that was dubbed by Gartner back in 2015 in January, and really it comes to a lot of the studies that they've been doing, projecting that by 2018, it's estimated that 25% of all corporate traffic is going to bypass the perimeter altogether. And I would argue that that number is already at 25% or even higher because of the adoption of things like Office 365, Google Apps, business units bringing in different SaaS applications in HR, Salesforce. Folks are accessing these apps from different devices. And then, of course, you have your custom applications that are now being hosted up in the public cloud on services like AWS, Azure, Force.com, Google. And this traditional layer of security is unfortunately pretty blind to all of these transactions and all of these transitions that are happening up in the cloud. So Cisco, right, traditionally a network-based company, sells great firewalls, endpoint solutions, malware solutions. Those solutions don't correlate up to this new cloud-first environment that the world is transitioning to, and that's really where CASB comes into play. And these problems that this cloud adoption is really bringing forward is presenting a shared responsibility model onto the customer. So when purchasing an application like Salesforce.com, like Corporate Box, Corporate Dropbox, Google Apps, Office 365, there's sometimes a misconception that these SaaS providers have the security handled for you and they're going to provide security with their tool. Realistically, the only security that these applications are providing internally is if somebody walks into one of their data centers or an AWS data center and physically steals a server and walks out the door with it. All of the data and all of the user behavior patterns and accounts are on the customer to protect. So again, that brings CASB. Gartner dubbed this term in January of 2015. They've now projected it as the #1 area of investment in planning that folks have been making in 2016 into 2017. And of course, this is going to grow. This is becoming a very noisy space. Obviously, I'm on here from Cisco talking about CloudLock, but there's tens of 20s of startups that are providing CASB-like solutions. A lot of acquisitions occurring in the market. And with this, Gartner is obviously ranking this as the #1 in their top 10 list here. The biggest difference with all of the noise and all of the vendors that are in this space are going to be the architecture and how they address the main areas of use cases that are addressed through a CASB. So all CASB vendors are going to look to achieve solutions for really 3 main areas of use cases, and Walt and Craig had touched on a few of these. But the first area is around the users and the actual accounts, so the corporate instances of Office 365, corporate instances of Salesforce, of Google Apps, of Dropbox, of AWS, and really starting to analyze user behavior patterns and picking out anomalies that are potentially malicious or indicating compromised accounts or potentially phishing attacks. So examples of looking like, Craig has logged into his Salesforce.com account at cStor at 9 a.m. from Arizona, and then at 9:05 a.m. he's logging into his Office 365 account, downloading content from OneDrive from Boston, Massachusetts. Scottsdale, Arizona to Boston in a 5-minute span is physically impossible. However, from Craig's account level, it's saying otherwise. Second area is going to be around data. Think more traditional content DLP here, cloud DLP. So not only is Craig logging into his OneDrive account from Boston roguely across the country, now what kind of data is he downloading from there? What kind of data is there? PCI data, PII data, HIPAA data residing in this OneDrive environment? And if that's okay from a customer standpoint, how is it being exposed? Is this sensitive data being exposed publicly with a URL by accident? Is it being shared domain-wide? Who has access to this sensitive data and how is it being shared and collaborated with? And then thirdly is going to be around shadow IT. So not talking about Office 365 and Google and Salesforce that are corporately sanctioned by organizations, but how about the applications that are roguely traversing the network or that end users are accessing to do their job in a productive manner. However, these applications are not corporately sanctioned. Getting you visibility into these third-party shadow IT applications is really an important feat when evaluating a CASB. So with that, like I had mentioned, CASB has been around for quite some time. The term actually was dubbed in 2015. The biggest difference with how all of these use cases are addressed from all of the different vendors is through the architecture. And here's a timeline here on kind of the evolution. So back in 2013, when Salesforce really started to take off and it was a big Google Apps push, there's you could call CASB vendors. Back then it wasn't called CASB yet. But the concept of putting an encryption gateway between the user environment and the SaaS environment really emerged. From there, that turned into, kind of dovetailed into a forward or reverse proxy mode in around 2014, coupling that with discovery reports and log ingestion from firewalls and from networks to give you that visibility into shadow IT. And then when that term CASB really hit the market, that's when a lot of these vendors really also hit the market and a lot of acquisitions started happening. From there, it really became a multi-mode approach to CASB. So coupling a forward or reverse proxy, the ability to ingest logs, and also the utilization of public APIs that the sanctioned SaaS providers provide to you as their customer, starting to integrate CASB vendors with these public APIs. Now, the market has moved towards this API approach because now that these proxied approaches have been around for a few years now, it's actually proven that these reverse proxy architectures are quite difficult to stand up and can often create latency and really affects the experience on the SaaS application itself and oftentimes can actually break the functionality of the SaaS application. So we would stress when you're evaluating the CASB market to look at an API-first approach and also from a platform perspective. And how that API architecture works is really around looking at the SaaS applications that are corporately sanctioned in the environment, and then picture the API CASB, such as CloudLock, as an enterprise security API. The way that we install the product is we're just connecting the CloudLock API to the API that is publicly sanctioned by the SaaS provider itself. It's done quite simply. There's nothing on-premise. We're not putting agents on any devices. We're not putting any form of a proxy or a gateway between the actual SaaS environment and the end user environment. We can actually stand this up, and any API-based CASB can stand this up rather quickly in just a matter of minutes by connecting the API. Any questions here? I'll pause for a few moments.
I think we're good to keep going. Oh, actually, sorry, there is one question that came in. What differentiates CloudLock from competitors, Sean? Can you speak to that?
Sure. So I would say the architecture. Today, most of the competitors that you're going to see on the market are a combination of API integrations and forward or reverse proxy integrations. CloudLock has been working with strictly API since 2011. We're very well versed in API architectures, so I know it does sound like if anyone can connect to an API, any vendor can. However, we have the experience in being able to work with the actual workflows and response actions that are available through the APIs and kicking off workflows and automation to do things like remediate inappropriate exposures, kicking off selective encryption when available through the SaaS provider, quarantining sensitive data into private folders or private objects within Salesforce, and also sending notifications to users explaining what they did wrong and then how to go ahead and fix it next time around.
Great, thank you.
So again, the way that we would install this is we would get on the phone with the global admin to one of the SaaS providers that you're using in your environment. We'll use Salesforce for an example. You go into the admin console, you can either create an API token to install into CloudLock, or you just create an OAuth flow and log into CloudLock with the Salesforce environment. It's really quite simple. So again, just to kind of the differentiation there and what's available from the API and proxy perspective. Proxies are going to miss a few things in the environment, which is really why APIs have taken off and the market's kind of moving to that approach. As you're using these SaaS applications, you're typically collaborating with unmanaged users that are not part of your domain. You need to have the visibility into what kind of traffic and what kind of data is traversing in and out of these applications. If you're just relying on some form of a proxy to see this data, a lot of this data is going to be bypassing that perimeter and that proxy altogether. Going back to my kind of original point on bypassing the perimeter altogether by 2018. Also, any traffic that's syncing between multiple SaaS applications. So if you have, if your company sells anything, right? I'll talk about software companies, for example, with cStor and Cisco. A lot of Salesforces will have emails syncing from Office 365 to Salesforce, emails that are going back and forth, threads between customers, syncing these and logging these in Salesforce for additional data, syncing things from email and OneDrive to Box, between Google Apps and Dropbox to ServiceNow. Any of that programmatic cloud-to-cloud traffic isn't going to be picked up by a proxy, whereas an API it would. Again, I mentioned, I won't reap on this here, but functionality can be quite affected by a proxied approach here. And one last point here, with an API, you are able to retroactively scan back in the environment to all of the data at rest since the inception of that SaaS application within your environment. A proxy is only going to be able to see that data in transit and not be able to backtrack and all of the potential exposures and violations that might already exist within the environment. So just as a high levels buyer guide, I would encourage, and of course I'm a little bit biased here because I do work for an API-based CASB, but you want to first take a look at cloud native approach, quickest return on value here, quickest to stand up, easiest to really prove the value and take a look at what your environment looks like today, being able to scan back retroactively. You also want to look for a vendor that has some added human intelligence on the back end. So Cisco does have both the Talos team and the CyberLabs team that are consistently looking at third-party shadow IT applications, ranking applications, putting them into our product, also evaluating malicious IP ranges, collaborating with third parties on, also feeding that intelligence into the product. Also, you would like to, of course, look at, if you're utilizing things like AWS, you want to have a CASB that's not only going to cover that SaaS environment, but also that AWS environment as well. So now I'll get into those three areas of use cases in a little more granular detail. First, I'll touch on the user behavior analytics piece, so that the users in the accounts use case. So how do you protect these user accounts? How do you identify compromised accounts? How do you see when there's rogue logins coming in from across the world that just don't physically make sense? How do you notice when folks are downloading files at a high rate and then leaving the company and bringing these things with them? So you want to have more so a heat map of where all of this activity is coming in from, right? Why is there things happening over in Russia when we don't have any operations in Russia? Is somebody on vacation, or is this truly a compromised account? Starting to blacklist and whitelist known ranges and known locations where you do have operations coming in from. So through the API, we're gathering raw events, and we're seeing all of the raw activity through these API calls that are being made between the SaaS providers and Cisco. We're seeing that on average, 1 in 5,000 of these raw activities is deeming to be a sensitive activity or suspicious or malicious in intent. So with 5,000 activities, it is pretty tough to sift through yourself and maybe just feed through your SIM through an API connection and sift through and pick out what might be suspicious and what might not be. So with the CASB that's using these API connections, we're able to pinpoint that needle in the haystack and really find that 1 in 5,000 that could be a potentially compromised account and take a deeper look into that. So looking at some live customer environments here, this is an organization that I worked with in New York. They had a VPN location in northern Oklahoma, and what we were seeing was that this user, we'll call him Johnson, logged into his corporate Google Apps account. We'll call it at 9 a.m. from the Bronx, New York. Then at 9:05 a.m., we're seeing that same user with some raw activity and API calls being made from Nigeria. What that looks like on the back end of the product, as you see here, user Johnson has 2 successful logins from HQ in the Bronx. Moments later, 2 login challenges from Lagos, Nigeria, and then actually a successful user login from Lagos, Nigeria. All 3 of these Nigerian-based locations are associated with known spam IP ranges. Another example here, so that was actually a true hit. That was a compromised account that was hit with a phishing attack days prior to the CloudLog API install. Another example here is abnormal file downloads. So looking at things like a 3-month span of time here in this environment. That on the lower end here we have Christopher, Lee, and Frederick with between 2,000 and 3,000 downloads in a 3-month span of time. On the higher end we have users Stanley and Priscilla with between 6,000 and 9,000 downloads from OneDrive in a 3-month span of time. So we took a deeper look into Stanley and Priscilla because that is a fairly high amount of downloads in 3 months. That actually proved out that Stanley and Priscilla were part of the marketing team and were consistently dealing with a lot of content, and it really made sense for them to be downloading this much data. It was part of their job. The real outlier that stands out in the anomaly that we're detecting here is the first user, David. So David had 50,000 downloads in a 3-month span of time. That's really saying one of 2 things. David's account is compromised, maybe he was hit with a phishing attack, and there is a malicious outsider out there actively downloading intellectual property from the corporate OneDrive or Google Drive environment. Or number 2, David is a disgruntled sales rep and he's going to a competitor and he's bringing everything with him and he's walking out the door with 50,000 files. So now we'll move into more of the content DLP use case and how do you protect your data in the cloud in that second use case. So really the nature of our network traffic has changed, and all of the data that we're traditionally used to hosting on-prem has moved into the cloud. That's no mystery here. So you want to be able to have the ability to identify where that data is living and then deem if it's in the proper space within the cloud. And if it's not, let's take some automated workflow action on this. So sending user notifications to coach them up on how to better interact with these applications. Go ahead and automatically revoke that file share, or maybe quarantine the file and selectively encrypt that file within a custom object within Salesforce, or within a quarantine folder within Dropbox or Box that only the admin has access to. So some live examples here, social security numbers being inappropriately shared within box.com, or being shared with the entire domain being shared publicly. Roadmap exposures, right? Here's a real estate company that I work with that had some architecture designs that were publicly available in Dropbox, and these were actual future plans that shouldn't have been exposed. Usernames and passwords that are dropped into Microsoft Word documents and then being shared with multiple employees within the domain. Maybe that's okay. However, you do want to have an extra set of eyes and visibility into where these sensitive docs live, who has access to them, and how are they being shared. Are they being shared publicly by accident? Are they being shared domain-wide by accident? And again, a lot of these inappropriate exposures are done unintentionally, just simply because users haven't interacted with some of these cloud applications before, and they quite frankly just don't know how to properly utilize and share these docs with each other. PCI compliance, this is a huge use case. Should you have PCI data residing in the cloud? Again, if that's okay for you to have PCI data up there, if you have to remain PCI compliant, are your SaaS applications being pulled into scope for PCI audits? Again, how are these credit card numbers or these payment information being shared? Then coming back to this slide again, when we're identifying this data, how are we going to react to it? Let's build a custom automated workflow that can go ahead and remediate all of these bad happenings and these policy violations in an automated manner. Next, I'll move on to Shadow IT. However, are there any questions before we hit on this last area?
Of course, the proverbial question that I always ask CASB solution providers is, if you have to explain shadow IT to your mother, how do you explain shadow IT to your mom? She never asked that question, by the way, to you, but she did ask it the other day, so I thought I'd just carry it over to you.
I was going to say, Walt, are you talking about my mama?
No, it's my 81-year-old mother, and she's probably gambling right now, and she was thinking about shadow IT at the same time.
Yeah, you know, it's a typical workflow when she's out at the casino. So how I would explain shadow IT to my mother would be that it is when users are doing something on the internet that the company doesn't allow them to do.
I'll let her know.
Sounds good. All right, so at Cisco, we take a slightly different approach to shadow IT. If you've looked at other CASB vendors in the past, or as you continue to look at CASBs in your evaluations here, you'll see that most shadow IT is done through log ingestion. However, we've been able to utilize our API integrations with applications like Google Apps and Office 365 to discover what kind of applications are hooking into these applications through OAuth. So similar to how if you go to Facebook.com and instead of logging in with your own personal credentials, just logging in with your Google account, that option to just click on Login with Google. That workflow is often done in the workplace as well when authenticating applications to use that are shadow IT apps. Authenticating them in through OAuth to your Office 365 environment or to your Google environment. You want to have visibility into what kind of applications are hooking in there. So at CloudLock, we've been discovering these apps since back in 2011. Right to date, we have about 250,000 third-party applications that are tying into environments through OAuth. You want to have the visibility into what the applications are out there and also what risk these pose. So we see that about 30% of OAuth-tied applications are of high risk because of the access scopes that they are asking for or their reputation. 15% are low risk, and about the majority at 60% is at medium risk. So an example of this is a customer environment that I looked at here. We're seeing that a W-2 was being stored in corporate Google Drive. We pointed this out. They said, that's fine. As you can see in the red box here, it's not exposed publicly. It's not exposed domain-wide. It's private only to the owner. So nobody outside of this specific owner would be able to view this W-2. It's actually not the case. If you look at it in the next step from a shadow IT perspective, we need to see what third-party applications this file owner has authenticated into their corporate Google account or their corporate Office 365 account. More importantly, which applications are asking for full data access or the ability to act on behalf of the user. Therefore, those third-party shadow IT applications have the ability to gain access to that employee's W-2 or anything else for that matter that's being stored in the cloud application itself. Guys, that is all I have. Any questions here before we wrap? I appreciate everyone's time today.
Thank you so much, Sean. We do have a few questions coming in, and I'll just remind everyone, if they have questions, to post them to the questions pane. And we'll take them now. We've got a few more minutes. There are a few. First question, how is this product deployed in production? Can you speak to that, Sean?
Sure. So back to the, I won't go back to the API slide and shuffle through here, but what we do is you have your CloudLock pre-sales team would just get on the phone or a WebEx or a GoToMeeting with the admin of the SaaS application that you would like us to install the API on, and then they just authenticate the API token, and then that same OAuth workflow that I touched on Shadow IT is the same way you can actually install CloudLock. Takes about 5 minutes.
Enough. Yeah, that's always good. Next question, what applications do you have connections built with?
So today, Cisco CloudLock has API connections built with Office 365, Google Apps, or now known as G Suite, Salesforce.com, Dropbox, Box, ServiceNow, Slack, AWS, and Force.com.
Great, thank you. Last question, and then we'll let everyone wrap with a few closing thoughts. But what can you do once you see the odd behaviors? So we talked about, you talked about the odd behaviors, but can you talk a little bit more to the action steps once they're identified?
Sure. So we utilize API connections with other third-party applications. For example, like a single sign-on or an identity provider, I'll use Okta or OneLogin as an example, some of the big players on the market. Through those panels, you're able to enforce things like multi-factor authentication, shut a session down. So when we see these odd behaviors, we're actually able to make an API call out to your identity provider to enforce governance from their perspective and from their capabilities. So again, through these API connections, we're able to utilize the capabilities of other providers themselves.
Great, thank you. We're just running a little bit long on time.